In this example, we're going to learn about the distributive property. And we've actually already used the distributive property when we were learning how to multiply using the area model when we partition the rectangle into the different pieces. But now we're going to use it specifically in an application problem where there's just going to be two pieces, and the other ones we broke the rectangle into 4 pieces. So let's see how this works using an application problem. So I'm going to highlight my givens. Linda has a rectangular flower bed that is 10 feet long and 4 feet wide. Okay, notice we're given this picture. Here's the 10 feet and here's the 4 feet. She is going to plant morning glories and tulips. She wants more morning glories than tulips and decides to divide the garden as shown below. So this piece represents tulips. That's where she's going to grow tulips, and here's where she's going to grow morning glories. And they didn't give us these numbers, they just included them in the diagram, but I'm going to highlight them right here. So the tulips, this is 3 feet. The morning glories have length 7 feet to total the 10 feet, and they both have width 4 feet. So let's look at these questions. Determine the total area of the garden by multiplying its total length times its total width. So its total length, so I'm looking at the whole garden now, not looking at the 2 pieces, is 10 feet times 4 feet. So 10 feet times 4 feet, which is, we're going to write this as 40, this means square feet, so 40 square feet. So we haven't talked too in depth about area. That's covered more in geometry, but we did say that the area of the inside of a rectangle, you can find it by multiplying the dimensions, the lengths of each side, and this would give us basically 40 square feet that would fill up the center. Now let's look at the total number of square feet that will be planted with tulips. So notice this is the tulips, and we have that its length is 3 feet and its width is 4 feet, and I know that from over here. So to find that, we'll have 3 feet times 4 feet equals 12 square feet. So 3 times 4 is 12, and the units, I could fill these up just to remind you for this one. I could break this into 3, break this into 4, and here would be the 12 square feet. Now it asks, determine the total number of square feet that will be planted with morning glories. Show what quantities you multiplied. So the morning glories are in blue, and we have 7 feet by 4 feet is the length and width of the morning glories. So 7 feet times 4 feet. So 7 times 4 is 28, and we have 28 square feet. So we found tulips, morning glories, and the area of the entire garden. Now it says determine the total area of the garden by adding the area planted with tulips and the area planted with morning glories. So remember, it was on the last slide, but you should still have it on your paper. The tulips were 12 square feet, and the morning glories, which we'll call MG, they were 28 square feet. So to find the total area of the garden, we can add the 2 pieces together. These 2 pieces make up the whole. So we'll add 12 square feet plus 28 square feet is a total of 40 square feet. Okay. And remember, this is the result we got in Part A when we found the total area of the garden just by doing 10 times 4. So it should make sense that these are equal. So now, using the equation below, describe in words how it represents the 2 ways we found the total area of the garden. Okay. So here we have 4 times 3 plus 4 times 7. Well, I'm just going to draw little arrows. 4 times 3 was the area of the tulips. And we added that to 4 times 7, which is the area of the morning glories. So that's what this left side represents. And the right side, 4 times 3 plus 7, well, 3 plus 7 gave us the 10. Okay, so this piece right here is combining the lengths to the total length of the garden. Okay, so if we did 3 plus 7, there's the 10, okay, and that would be 4 times 10. And this is the result, which we call the distributive property. So basically what the distributive property says is that 4 times 3 plus 7, where 3 plus 7 is in parentheses. Now remember, we would need to add these first by the order of operations because it's in parentheses. But the distributive property says this is equal to 4 times 3 plus 4 times 7. And a way that people like to think of this is you can multiply the 4 times the 3 and then add the 4 times the 7. And we can think of that as distributing the 4 to the two addends in parentheses, 4 times 3 plus 4 times 7. In addition, this works for subtraction. So if we had 3 times 6 minus 4, okay, we could multiply the 3 times the 6 and then subtract the 3 times the 4 and find the result. Okay, so this is a different way. In these cases, it'd probably be easier to do 6 minus 4 first is 2, and 3 times 2 gives us the result of 6. But sometimes we'll need to look at things in different pieces to be able to combine them, like we did when we did the multiplication using the area model. And also when we get to algebra, this is going to be an incredibly useful result, because lots of times we'll have unknown numbers in here, and we won't be able to combine what's in the parentheses since one of them is going to be unknown, so we're going to need to use this property a lot. So it's very useful, and now we're going to practice some more in the next video.